Hello, today we will be presenting our restaurant reservation system using Python programming. Hello, today we will be starting an introduction to our restaurant reservation management project. This is a two-part code with a simulation for a restaurant reservation system, primarily used to manage restaurant tables and customer reservations. The program works through a series of functions to implement the problem of time and table allocation. One of the codes are mainly used to handle time-related calculations. It is suitable for situations where time variances need to be handled and calculated. And second codes help to manage restaurant bookings, where customers are asked questions such as whether they are seated separately or not, preferences for the view around the table, how many people are coming to dine, and so on, ensuring that there is flexibility to respond to the needs of different customers. We will start by introducing the three main components of the time module, which is time to seconds, seconds to time, and the second component is start duration to end and start end to duration, and the third component is compare times. Time to second and second to time functions, which allow mathematical operations to be done. Time to second function converts time in string format, which we get from the user, allowing him to type it in a convenient way and a clear way, to time expressed in numbers of seconds, with which math could be done. Let's wait. Can we 1 second? Can we pause the recording? Actually, you can cut the audio. Yeah. Okay. After this math, in order to show the results to the user, resulting in number of seconds, is obviously converted to seconds to time. Time module helps us work with time, make some calculations in order to find the third variable, knowing two others, and using time duration to end and time end to duration functions, provided by user among start time and end time and duration variables. Later in the main program, these three variables will be shown to the customer as a reservation info to make sure everything is input properly. Additionally, the time model's compare times functions let us check tables whether with preferred view or not for their availability by checking each table for potential overlap with previous or existing reservations of this table. Overlap of current reservation and previous reservation for concrete table is not allowed since it causes problems and conflict which lead to a moral and ethical issue.
All five functions in time module, time to sec, sec to time, start door to end, start end to door, and finally compare times have some similar arguments. Show, represent, indicate, which influence their results. The only difference is that if that argument equals to 1, function will do calculations and follow them by explanations and detailed description by presence of print functions. While that argument equals to 0, function will do calculation, so we'll have some same logic, load, will return same variables and same results for same inputs, but will not provide description. It became necessary to make this branching since those five functions are going to be called in main program several times, and in some cases they are only supposed to return results without showing something. Otherwise, they will overload our console and will make user overwhelmed. So it's enough to call them once to show the overall situation to user and then call them without showing anything. Time to sec, sec to time, show equals to 0, start door to end, start end to door, represent equals to 0, compare times, indicate equals to 1. Since start door to end and start end to door and compare times functions are based on basic time to sec and sec to time functions, they can provide some values as parameters for these basic functions inside of own logic. And these values will override values of arguments written as default values shown in table above. This feature was leveraged, then was decided to put the same value for illustrative argument which the head function has for its illustrative argument. Basically, it means that if we call compare times function, the argument indicate equals to 1. So in this case, we want to show in console detailed description. Then the same value will be assigned to illustrative argument show equals to 1 of our functions, time to second, sec to time. This function is based on. The idea of converting values from one format time string to another seconds number, the purpose of executing calculations in easier way came from another field and attempt to build application for it, surveying technology. Surveying technology alphabet consists of real complex angles, consisting of 3 parts rather than usual one, degrees, minutes, and seconds. Attempt to operate the angles in such format was partly successful in terms of results, but definitely not in terms of time and effort. Need for numerous tricky conditions for digits and off numbers was acknowledged. The smart approach to cope with that was the use of another temporary format to make calculations decimals. We divided there, here we multiply. Division is always harder than multiplication since it begets decimal odd values. The question emerged, is it possible to use approach we used here, there? Will it make coding easier? Time models, time to second, sec to time functions, performance and workability was checked by do-redo chain. Time in string format was converted to seconds, then resulted seconds were converted back to time in string format. Obviously, result of this change should be the same as the input provided to it. The rest three functions in time model were checked by using common approach of trials. Main program. Implementing of code functions directly related to the considered problem of booking was done inside of main program code, which uses previously explained time model, and which itself is used by illustration model. The approach to write this code is mixed as well as the logic and philosophy. It implements two general approaches in coding world. Function programming and object-oriented programming. First part of code where the table entity appears, so the focus is objects and classes, static, is written with the use of object-oriented programming approach, while the second part of code there we operate with tables and data, so the focus is actions now, dynamic, uses functional programming approach. The popular terms in programming called class and object can be explained by analogy. Class, for example, humans, cars, and their corresponding objects. Certain person, certain car, for example, Ferrari. Then we declare class, we can create properties and methods for that class. Properties here usually have default values. For number is 0, for strings is just empty string. Tables essential properties we considered ID, view, capacity, is it free, table type, and the list of table types and the dictionary were created. Each time we create one more table, we assign to it capacity which depends, due to match dictionary, on the table type. Since task says to have tables with 4 seats capacity, we put that value as default one. However, we could give an opportunity to our user to choose how many tables of which types she has.
Right now we'll talk about the table creation part. So in the table creation part, we have this program is dedicated to the owner and user at the same time. And interaction with the owner happens during tables creator function process. The information we want to get from the owner is how many tables he or she has and which view. The information can be entered by an owner in two different ways. One of them should be chosen in the beginning. The first way is the separate way, where you put in view one, view two, and like the corresponding number of tables per each view. And the order is quite important to this one. Then there's the second view, which is the second way, which is the combined way. There's view one, and then you put number one. Then view two, and then you put number two. And so in both ways, we use the split function to get values separated by the comma. For separated way, we use views, and each view is table numberless. While for a combined way, we choose the temporary views and their tables number one by one list, and then by loop and iterating through these lists, we form two lists mentioned above. After that function implements that it should go according to its name function tables creator function creates table in two loops. First loop iterates through views entered, while second creates entered numbers of tables with specific view. List tables is the list of tables is being created here. After another loop iterates through this, it creates the tables list to assign to each table its ID value, which equals to the iterator value.
As a table filter, actually it would be better if that function was called table filter for availability, but was decided to leave this name of now. Tables filter function creates forms and returns free tables list and counts returns number of the free tables. It has indicate value argument which it assigns to used compare times function table feature function use loop which iterates through tables list. It compare end time of last reservation for this table and the start time of current one for the same table to check for overlaps. If overlap doesn't occur, then certain table availability property is free is assigned value 1, which means free available. And then the same loop checks that value which is assigned either 1 or 0 before. And if it is 1, then this considering certain table is added to the free tables list. And once loop iterates through all tables and the free tables list is formed, the calculation of the length of the free table list gives us a number of the free tables value.
The function interacts with user and by input functions collects the data essential to allocate user and his group properly questions about name and the contact demonstrates just friendly communication, although they are not used further in our code. Nevertheless, a date about name and the contact can be stored in some list and used for statistical analysis. Next.
Allocate customers. Allocate customer is in nature one large while loop consisting of outer loop div k iterator and inner loop div e iterator. While loop has several conditions, all of them should have true value to let while loop execute. Basically, number of guests which we are going to allocate should not be 0. If the variable number has 0 value, then it means that either we already allocated all guests or there is some error. We are assigning to variable number value 0 in some cases in further code lines to indicate that we placed all our guests. Or subtract value of people, then the capacity of certain table is not enough to allocate all guests in group.
Guest guest number exists. Variable is the null argument. Initially, that variable is type 0 value is set to be 1 when the response
你重新读，你重新读，
available.
重新读。
It's okay, it's okay. I can't read.
A guest number exists variable is the null argument. Initially, that variable is assigned 0 values. is set to be 1 when the restaurant's number of available seats of is not enough, or when number of per-read view seats available is not enough and user doesn't agree to place some of his group members with tables not with preferred view, or when he agrees but again number of all seats available is restaurant is not enough. New customer location process prevents the while loop from being executed when not needed. When user administrator didn't want to continue allocation process, so when no new guests come, probably at the end of the working day, but more code can be developed. Not only so we will not stop code like that though. Next, if user confirmed that view is important for him, then we need to focus on view tables so they are considered as input tables for further function, called the further and described above. Otherwise, all tables are considered as input tables. Later, we will give capacity summary, and in some cases, we'll suggest user to change his mind. Next, we have code to output several information blocks. The first one is table with specified view. The second one is comparing times for tables with or not preferred view for tables availability checking. The third one is capacity summary. The last one is possibility to allocate all people.
Alright, in outer K loop, we are iterating through each table in table's input list. Availability of each table is checked. If the certain table is available, then the capacity of it is checked. And if the number of the people in group is less than capacity of current table, then we simply place our people. Assign the number of variable value to 0 and break the loop. Else, if a number of the people in group is greater than capacity of the table, which is and the number of the free table is greater than 1, meaning that we have another free tables other than one, just consider it. Okay, and then we will set people that this table can contain. We will subtract that number of the people from number variable. And for the rest of people, we will provide another table in second inner loop E. And again, if the capacity of the second table will be greater than number of the rest of people, we will provide them that second tables and will assign number variable to 0 and break loop. Otherwise, if it will be less than number of the rest of people, then we will repeat all steps starting from K loop. Each time we provide to guest some table. We update start time and end time properties of it. So when the possibility of providing this table to next guest will calculate it. End time will be already finished and update. And the main loop is the place where all functions are called from meet customer and the tables manager and allocate customers if user wants to allocate new group of guests. Well, the last one is the main loop itself, which is a recursion function. Okay, we could manage without making inner loop E by using only one outer loop K. But then we wouldn't have a diversity of Ripley's answers. We describe the difficult and tricky process how two loops work together and illustrated in detail that by using Figma application using two loops we underlined text point about ability to join two tables together. Replace your first table, your second table.
Table visualization. Code. The illustration function generates ASKII art based on the availability status of each table, free or busy. Functionality. Provides a visual representation of table availability using ASKII art. The number of all tables is fetched and then stored in nums, and the illustration function is used to illustrate the state of the tables. The status of every two tables will be combined into a string such as free, busy, and added to string types list. Generate a list of table numbers and print it. Then let's move on to the next session. Print the corresponding table layout graphic based on the data in the state string list, string types list as above. Empty tables are represented by black and busy tables are represented by these dashed boxes. The rest here. Finally, this code mainly shows how to display the corresponding graphical representations based on the idle and busy status of the tables, helping the user to visualize the current table usage in the restaurant. To conclude our application part, as for the vision of the program, we designed it with the hope that it would be used to help people manage restaurant reservations, record and assign customer demand for tables. It can be used for seating arrangements in places like cafes, restaurants, or some larger public places. Here we have our design. We created it together. We have here some different type of tables and depending on the type of table we have different number of seats. We also wanted to integrate into our program to consider baby seats, and by gray seats you can see that this certain seat is busy already. Yes, and also we have air conditioning, airflow tracing, windows, and just light emission, and also have different views. To the left side you can see some water body, maybe ocean or sea, and to the right side you can see just forest or field. And we have rest zone. We also could just count how many guests we have still unserved. We also have outer zone, and we can provide to our manager or user some statistics in numbers, time, finance, guests, restaurant, architecture, features, and capabilities. So it will help us to provide math in our program, and it will help then user to upgrade the restaurant. Next conclusion here. Overall, after running the provided code, the restaurant benefits from the following specific functionalities. The system allows the restaurant to manage the reservation process efficiently by creating and managing different types and quantities of tables. Customers can input their reservation details such as name, contact information, number of guests, reservation start time, end time, or duration, and indicate their preference for a specific view. The system intelligently allocates tables based on customer requirements and real-time availability, ensuring each party is seated appropriately. Additionally, this system dynamically illustrates the current status and availability of tables, enabling the restaurant to monitor and manage seating utilization in real time, thereby enhancing booking efficiency and customer satisfaction. Thank you.